This question is about elements in period 3 and their compounds. When a piece of sodium is added to 200 centimetres cubed of water in a large beaker, a vigorous reaction occurs. The temperature of the water increases by 25 degrees C. Give an equation including state symbols, so sodium's a metal, is added to water, a liquid, to say what occurs. So we get sodium hydroxide forming and hydrogen gas. Now we just need to balance our equation. So there are two ways to balance this. You could notice that the sodiums and the oxygens already balance and just achieve the balancing by halving the moles of hydrogen gas, or you could double everything except hydrogen, so have 2 moles of everything except hydrogen, and you would get the same outcome. Both would be correct. Suggest why it's dangerous to react a similar piece, so the similar size piece of sodium, but with only 10 centimetres cubed of water. So if the amount of heat energy when spread out over 200 centimetres cubed of water allowed the water to go up 25 degrees C, imagine that amount of heat energy being evolved in only 10 centimetres cubed. The amount of temperature rise would have to be phenomenally much larger, because 10 centimetres cubed is a 20th of the size. So imagine having a 20th times increase in the temperature rise. So that would be a massive increase. The test tube would get very hot. Things might be so vigorous that it might come out of the test tube. It might even make the test tube explode because of the amount of heat and gas being evolved. So it's given an equation for the reaction of phosphorus 5 oxide. So we need to remember that if we were trying to just look at the oxidation states, we might think, well, phosphorus 5, oxide 2, so P2O5. But we have to remember that the formula for phosphorus 5 oxide is P4O10. And when it reacts with water, it's a non-metal oxide, and non-metal oxides are acidic, so it makes the acid, which in this case is phosphoric acid. Now all we need to do is balance it, and because there was 4 phosphoruses in P4O10, we make 4 phosphoric acids, and if we look at that, we'll need 6 waters to balance that. This phosphoric acid is a strong acid, so quite a low pH of 0, pH of 1. Explain in terms of crystal structure and bonding why silicon 4 oxide, SiO2, has a higher melting point than P4O10. So structure, SiO2 is macromolecular. P4O10 is simple molecular. So more energy is needed to break many strong covalent bonds between atoms in SiO2 than to overcome weak van der Waals forces between P4O10 molecules. So simple molecular things have intermolecular forces. Macromolecular things have covalent bonds between the atoms. An element in period 3 forms an oxide that is insoluble in water. It reacts with sulfuric acid and potassium hydroxide, which means it's amphoteric. So that's the clue. The clue that it's going to be aluminium oxide as the insoluble oxide, because aluminium oxide and silicon dioxide are the insoluble oxides, but only aluminium oxide is amphoteric. SiO2 is acidic, but Al2O3 is amphoteric. So it says give a formula of this oxide. So we're going aluminium oxide, and give an equation for this oxide's reaction with sulfuric acid. So this is one of the easier ones, because when aluminium oxide acts as a base, that's kind of what we would expect from metal oxides. So it's what we're used to doing. We want to make aluminium sulfate. Now, because aluminium's a 3 plus and sulfate's a 2 minus, we would need 2 Al 3 pluses and 3 SO4 2 minuses. And then we're making salt and water because it's a standard base plus acid reaction. Now we just need to balance our equation. And the aluminiums are already balanced, but because there's 3 sulfates, we need 3 sulfuric acids, which produces 3 waters. Give the formula of a hydroxide, so that's with OHs in, of a period 3 element used in medicine. So that's a clue back to the first year. Magnesium hydroxide is used in indigestion remedies. And then identify the element in period 3 from sodium to chlorine that has the largest atomic radius. So this is about remembering that atomic radius decreases across a period because all the elements in the same period have the same number of shells, but as you go across, they're getting more protons. So sodium has the least number of protons and the weakest attraction to that outer shell, and so the largest radius.